We need to expand, right? We have 3 properties. If I have multiplication, what am I going to replace it with? Addition. So I have log base 6 of a cubed plus log base 6 of, oh shoot, there's a 4 on the outside. I needed to multiply the 4 to the exponents first, right? So this should be 12. And what's b? 4. Why is it what, huh? Yeah, see the 4 is out on the parentheses. So 4 times 3 is 12. 4 times 1 is 4. Then I need to bring those exponents out, right? So I get 12 log base 6 of a plus 4 log base 6 of b. Got a question? Okay. All right, number 3. I have to change this to all exponents first. So I have log base 4. Can I what? Just review. You should know this like that. Okay, cube root is written as an exponent 1/3. Okay, times y to the 1/3 times z to the 1/3. These are all plus signs. So I'm going to have 3 log base 4s added together, right? Then I'm going to bring the exponents out in front, right? So 1/3 log base 4 of x plus 1/3 log base 4 of y plus 1/3 log base 4 of z. That, okay, number 5 is just like number 1. I have to distribute that exponent first. So I have log base 2 of 5 to the 5th times 3, 5 times 5, 25th. I'll do exactly what I did up here. That 5 is going to come out front, base 5, plus log 2, 3, log base 2 of 3. I should have left room for my 25 up front. Number 7, everything's exactly the same, except for instead of a plus sign, I'm going to have minus sign because of division. Okay, first, multiply the exponents. Log base 3 of 12 to the 2 times 4 is 8. Divided by 5 to the 1 times 4 is 5 to the 4th. Log base 3 of 12 to the 8 This division becomes a subtraction. Log base 3, 5 to the 4th. And move your exponents up in front. Okay? You're going to have to rewrite the square root of u, making an exponent. What is it? Don't forget it's root 2. What's the exponent of u? 1, right? This is the square root. It's going to be u to the 1/2. Okay, multiplication becomes addition. And my exponents come out. The square root is always 1/2. Cube root is always 1/3. Now, if I had a like u to the 2nd, then it would be 2/2. Okay, remember it's exponent over root. Exponent of the base u is 1 over the root 2. Okay. Did I miss something? Did they say they were going to go somewhere? Huh? Huh. Okay. All right. Multiplication sign. Oh, we have a power raised to a power. We have to move them out first. Log base 3 of 8 to the 4 times 5 is 20 times 7 to the 1 times 5 is 5. Can I do 2 steps at once here? I'm going to put a plus sign in. I'm going to bring the exponent out front, put a plus sign in. Bring the exponent out in front. Condensing is actually easier. Okay. If I have a number in front of a log, what is it? It's the exponent of the number, of the base, right? Plus turns to multiplication. I have log base 6, and I'm getting rid of one of them, a to the 6th, right? Times, I don't even need the log 6, I got b to the 30th. Yes. How about number 12? Instead of multiplication, I'm going to have a division sign, right? So I have x to the 4th. Well, here's my log 8. What? Oh. So I have x to the fourth divided by y to the fifth. Minus sign tells you division or multiplication. How about 15? Division again, right? So I have log 4. 4 is an exponent of 5. Minus tells me division. 4 is an exponent of 2. No, you don't even have to simplify. I don't care. Number 17. Number becomes an exponent of x. 30 becomes the exponent of y. Subtraction, so what do I do between the numbers? Divide my numerator, x to the fifth. Denominator, yeah. 19. 4 is an exponent of a, 2 is an exponent of b. Multiplication, log base 9 of a to the fourth times b to the squared. Number 21, we have to solve this equation. First of all, what kind of equation is it? Exponential, because they're exponents, right? What's the difference between number 19 and number 21? The what? There's an equal sign. That's the big difference. Here I can have an expression. Here, when I have an equal sign, what am I going to end up with? Yes, an answer. So I have to solve for A. A has to equal something. Okay? If I have to solve for A, I'm going to attack this term. I want that guy by itself. So I'm going to subtract 3 from both sides. So I get 6 to the A equals 53. Now, there's no common base. I can't do, I can't use a log. So what logs can I use that are on your calculator? ln or common log, right? Doesn't matter which one you use. Okay, so if I have the ln of 6 raised to the a, what can I do with that a now? I can move it out to the front, right? So I have a times ln of 6 equals ln of 53. Now this is multiplication. Now I can divide by 6, ln of 6. It's my a by itself. What is ln of 53 divided by ln of 6? ln 2.21. I need one more decimal place. That's thousand. Okay, 23, not 22, 23. I have to get my term by itself, so what am I going to do first? Divide by 9.7, right? $91 divided by 9.7. 9.3. Now what? ln or log, doesn't matter. Nope. Two n ln of 14 equals ln of 9.381. See, there's multiplication between all of this, right? So I'm going to divide by, remember I got to get n equal to something, right? So what don't I want here? Now, be careful, but we got two numbers there, so we need parentheses. In fact, let's not chance it. Let's put parentheses in. Okay. ln of 9.381 divided by 2 ln of 14. I get 0.42. Pardon me? Right. Because there's multiplication here. So you have to undo multiplication. Questions so far? Yep. You could use either one. Doesn't matter because on this problem it doesn't matter. Now if this was E or 10, then it would matter. This was E to the 2n, I would want to use ln. If it was 10 to the 2n, I would want to use common law. Other than that, you can use either one. I would use common log, yes. Exactly. Are we getting close to being done? Last page. Okay, I want to solve for, what is it, n? So I want to get the term by itself. So I'm going to add 1 to both sides. What? Congratulations. So I have 10. 8n minus 8.9 equals 80. Now we should use common log. Yep. Because that's going to do the base 10 for us. That gives us the 8n minus 8.9 equal, what is the log of 80? $1.903. Okay, add 8.9 to both sides. $10.803 and divide by 8. So n equals 1.350. And the last section, 7.5b, we're solving logarithmic equations, right? So instead of taking the log of both sides, we're going to exponentiate both sides, right? All right, let's condense this. I have log base 6. I have two numbers here separated by a plus sign. So what am I going to do with them? Multiply them. Exponentiate it. I have log base 6. So I'm going to make it an exponent of 6. I'm going to make this 1 an exponent of 6. 6 log base 6 cancel. 2 times x. 2 times negative 10. 6 to the first. Add 20. X equals 13, right? Do I need to check it? No, because it's a linear equation. Okay, it didn't have a quadratic in it. We didn't introduce a quadratic. Questions? 29. I have subtraction this time. What am I going to do with the numbers? X plus 6 is my numerator, divided by x, going to equal 1. Now, I guarantee you, for those people who aren't paying attention, you're going to do this. Guarantee it. I'll lay money on it. I'm going to cancel out that x. Can't do it. Yep, it's a quantity. How do I get, oh, first of all, I got to get rid of the log, right? Exponentiate it to base 10. What's 10 to the first? Now what? Yeah, I got to get rid of the denominator, so I'm going to multiply both sides by x. So I get x plus 6 equals 10x. What's x going to equal? Please reduce your fractions. Do I have to check it? Yeah, probably would be a good answer because you really should be checking your work. But you don't have to because it's linear. X to the first power. We never introduced an x squared. Okay, 31. I have a plus sign. What am I going to do with these two numbers? Multiply them. I'm going to put the x in front of the parentheses. Okay, I'm going to get rid of the ln. Exponentiate it. X times x. X times 29. Now I have a quadratic. So I get a solve for X. I'm going to have to get 0 on one side. Minus 62. X squared plus 29x minus 62 equals 0. And luckily, they gave us a very easy quadratic equation to factor. Only way to get x, x times x. This is a minus. They multiply to a minus, so I have to use a plus and a minus. Two numbers that multiply to 62 and add up to 29. That's right, 31 and 2. What does x equal? Do we have to check them? Yes, this time we have to. Okay, so I have the ln. I'm going to try negative 31 first because chances are it's not going to work. Negative 31 plus 29 plus ln of x, which is negative 31. Does that equal ln of 62? What do you think is going to happen here? It's not going to work. $31 doesn't work. What about 2? Plug in 2 instead of negative 31. I get 4.127 on the left-hand side, ln of 62. 4.127 on the right-hand side. X equal 2. One more. You guys are a bunch of idiots, man. I tell you, Addison, you're just an idiot. Log of 2 times 2x, what is that? 2x squared. 4x squared, right? Exponentiated to the base 10. So I have 4x squared. What's 10 cubed? A 1 with 3 zeros. Divide both sides by 4. No. Square root both sides. Unfortunately, 250. Square root of 250, and if that works, we know the positive is going to work. So log 2 plus log 2 times square root of 250, negative 250 squared. Does that equal 3? I'll tell you right now, it's going to. You know how I can tell? Well, besides that, Damn it. I got one too many. Yep, I don't have enough. No, it should have worked. All right, log 2 plus log of 2 times square root or negative square root of 250 squared X should be a real number. You're getting a non-real? It should be log 2 plus log, let's see, negative 250, square root of 250 squared is 250 times 2 is 500. 3. Somehow I'm typing this in wrong. Yeah, I don't know why it's not working. Hey, you're lucky I don't make you simplify the radical. $25 times 10, square root of 25 is 5, square root of 10. Yeah, somehow I'm putting this in my calculator wrong. But at this point, I don't care because